relatively small crowd, they said. Right, so greetings. I'm Keemink, and I'm a neuroscientist at the University of Edinburgh. What that means is that I study the brain, the thing in there, just hanging around usually. But I used to be more of an engineer. Now, engineers have a funny way of looking at the world. First, anything can be fixed with a hammer. Secondly, we can understand anything, and we can understand anything personally with the same hammer approach. Right, so here I was, with a brain, that for some reason no one has managed to understand yet, but hey, I'm an engineer, so I have this engineer's hammer, so let's solve the brain. Now, small disclaimer, it's a figurative hammer, because some countries it's illegal to try to solve a brain with an actual hammer, so I won't go there. So yeah, what I'll talk to you about now is what the brain actually means. Now, as I said, I looked at it as an engineer, and as an engineer, the first thing I compared the brain to is a computer. So, behold, the brain, the most complex object known to man. But still, it's quite simple actually. It's a computer with different specialized parts that each do their thing. So, for example, we have the eyes, the nose, the ears, which act as the sensors, and the rest of the brain then interprets that and makes you do things. For example, read your newspaper, attend a comedy club, forget your lines at said comedy club. Hopefully not, but we'll get there at some point. As a practical example of how the brain works. So, just as an example, what happens is that it's another example of the brain. Is that, okay, so there are your eyes, and they say to the rest of the brain, okay, guys, there's a certain arrangement of light coming in, not sure what it is, but take it or leave it. Visual part of the brain, back of your head, then goes, right, you can see some nice orientations, some circles, maybe some red, some orange. Yeah, okay, this was good. What do you think? Object recognition. Object recognition goes, right, there's a tail, there's some fluffiness, there's some big eyes. Oh god, this is gonna be embarrassing. It's a cat! It's a cat! Oh, that's so... So there you go, it's like a computer, except it's a bit more, you know, entertained by cats then. But of course, as I started studying the brain, I realized it's not that simple, because you have all those specialized parts in the brain, and each of those parts is itself made up of many, many small brain cells. And those brain cells are shouting at each other using short electrical potentials to try to do the things that that part of the brain is supposed to do. So, as a little experiment to imagine what that's like, I'm going to turn you, the audience, into kind of a mini brain. And the way we'll do that is I'm going to ask you to imagine that you're a brain cell. And you're a brain cell that really, really likes ducks and rabbits. What that means is that when you see a rabbit, you just continuously start shouting, rabbit, 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 rabbit. When you see a duck, you start continuously shouting, duck, 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 duck. So, everyone got that? Yes. I'm going to show you a picture, and I want you to shout out what you see and keep shouting it. Yes. Go. Duck, 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 duck. Rabbit, rabbit, duck, rabbit, 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 duck, rabbit, duck. All right, thank you, thanks for that. So just as showing, I could not make out what I was showing you. So that's kind of what's happening in the brain as well. So it's actually not so nice as a simple computer. You have all these brain cells are shouting at each other. So to come back to the earlier example of looking at something, it's not just the eye, but there'll be cells in the eye that like a very specific thing. Hang on, back a little bit. So what the cells are doing is they are shouting at each other at the top of their electrical potentials. And each cell is kind of obsessed with a single thing that they will shout to the rest of the brain about. So for example, the cells in your eye, they will be shouting about if what they are looking at is dark or light. And they will only be looking at a really small area of your vision. Right. So in your eye. Something really small just passed through my limited field of view. Me too! I didn't see anything. Shut up! So keep going like that, all the cells in your eyes shouting at each other. Meanwhile, visual part of the brain. I really like horizontal things. Yeah. They really give me a buzz. I'm more of a vertical kind of guy. You know, it really jolts my whizzies. guys, hang on. I think the eye is trying to tell us something. You're right. It's horizontal. See, horizontal. There's something vertical. Maybe something more curvature. I'm seeing some orange. No, red. They're definitely red. And so on, so on. They keep shouting at each other, trying to see what the eye is telling them. And then very messy. And so if we go no further into the mess that is apparently our brain, they'll be shouting more about things like dog ear, cat ear, dog tail, cat tail, cat tail. It's a cat. Oh, it's a cat. So end result the same as this kind of computer idea of the brain, but just a whole lot more messy. So you have all these brain cells shouting at each other, kind of like the House of Commons really, except a person comes out instead of a barely functioning government. And the second difference with the House of Commons is that there is a whole lot more brain cells than there are people in the House of Commons. So there's about 80 billion cells in every one of our heads. Now, what does that number mean? Let's have a few comparisons. There are more cells in their brain than there are people in this room. There are more cells in your brain than people in Edinburgh, the UK, or the world. There are more cells in your brain than the number of beard hairs in Scotland. There are more cells in your brain than the number of words you say in a day or in your entire life. It's not funny, but it's mind-boggling. If I keep making 80 billion more of these comparisons, you'll be here for about 12,000 more years. Luckily, my time is up, so I'll just leave you with this. The brain is kind of like a computer, yes, but a whole lot more messy. And maybe that's exactly why it works so well. Although then again, it doesn't seem to be working very well for the democratic governments. Thank you very much.